Okay, let's talk about surface integral. It's compute quantities like flux, mass, or area over 2D surface in 3D space. It helps calculate things over wavy surface like how much wind hit a parachute or how heavy a curved mirror is. We focus on flux because it's used in physics and engineering. Below is the real world example, and then the other side is math symbol for flux and area.
For the first question, here we need to evaluate the surface of the integral of f dot n ds over a closed surface S. The vector field is F is given that the surface S is a bundle of the solid cylinder. First, we apply the divergence theorem. We say the surface of the integral equal to the triple of the integral of the divergence of F over the volume Q. We find the value of F is equal to 16, and then we change x squared plus y squared is less than 16, z from 4 to 10. We can switch the cylindrical coordinate from r from 0 to 4, pi from 0 to 2 pi, and z from 4 to 10. Substitute the answer and we get the final answer is 1536 pi.
And our next step, we need to factor out the constant. Using the triple integration that we have, we need to integrate respect to the z, r and theta and calculate. First of all, integrate the dz first, after that integrate the dr, and then lastly, integrate the d theta. After that, multiply with 16 and we're gonna get the final answer 1536 pi.
These 3D figures show the solid region Q, which is bounded by the cylinder x to the power of 2 plus y to the power of 2 equal to 16 with caps at z equal to 4 and z equal to 10. We use this region to apply the divergence theorem, which allows us to convert a surface integral into a volume integral. The vector field we're working with has a divergence of 16, so instead of integrating over the surface, we compute the volume of this cylinder using cylindrical coordinates. And this figure was created using GeoGebra to help visualize the region and make the integration process clearer.
So for conclusion, divergence theorem connect a surface integral to a volume integral, convert the flux of vector field through a closed surface into a divergence of the field over the enclosed volume. Application, physics, engineering and mathematics. For advantage, simplify difficult surface integral, everything them a volume integral. For stroke theorem, related a surface integral to a line integral, convert to the curl of the vector field over an open surface. For advantage, it simplifies complex surface integral by computing them along a boundary curve.